Okay. Yes, Shen. Shen.
All right, everybody. So let's pick up where we left off. We're very excited to have Sean to keep talking about beyond preferences and AI alignment. So continuing the theme, thanks for joining us.
Yeah, thanks so much for having me here. Very excited to be presenting this talk. I'm Shen. I'm a sixth-year PhD student at MIT, working with Josh Hindenbaum and Vikash Mansinka. Really excited to present this talk on how we should go beyond preferences in the theory and practice of AI alignment. Before I start, I wanted to note that this is based on a very recent paper with my co-authors, Micah Carroll here at UC Berkeley, Mattia Franklin and Hal Ashton, which will soon be published in the special issue on AI safety in the journal Philosophical Studies. And this is, in fact, a philosophy paper. So even though I'm a computer scientist working in a cognitive science department, I kind of moonlight in philosophy sometimes. And it was really intended for an interdisciplinary audience. So I hope to translate a lot of the ideas that philosophers and economists have discussed to computer scientists working on AI alignment. And this is going to cover a lot of content, so I'm going to pause at particular points to take questions, but prefer no interruptions until then. Great, so just to get clear about the context of this talk, I think it's worth defining what I mean by AI alignment and how it relates to this other term, AI safety. And I'll start with this rather broad definition of alignment, which is the project of ensuring that intelligent autonomous systems robustly act in our perhaps collective interests. And I view that as distinct but related to AI safety, which can be described as the project of ensuring that intelligent autonomous systems avoid potentially catastrophic loss or harm to people or society. And one natural way to think that they're related is that, well, alignment just subsumes safety because one of our interests is not suffering loss or harm. But for the purposes of this talk, I think it's really important to emphasize another way these are related, which is that if you look at the intellectual history of how this term AI alignment became prominent, it was actually because it was viewed as necessary for safety. Right? And the reason it was viewed as necessary is because a core set of early thinkers expected that future powerful AI systems would look like expected utility maximizers. Right? And it's from this concern that the concept of alignment actually arose, right? To roughly summarize, if advanced AI systems are going to be expected utility maximizers, then it seems really important to make sure that they maximize the right utility function. So what utility function should we maximize? Well, perhaps the human utility function. But what are utility functions? They're just kind of representations of preference orderings that comply with certain rationality axioms if you take seriously the sort of decision theory literature. And so we end up having this notion that AI should maximize the satisfaction of human preferences. Right? And just so you know, I'm not making this up, this sort of framework for AI alignment is actually very explicitly argued for by Stuart Russell, for example, who argues that in order to build beneficial AI, we should build machines whose only objective is to maximize the realization of human preferences, which are learned from human behavior. And this focus on preferences or utility functions has really been the through line going back to the early papers by the Machine Intelligence Research Institute, arguing that we need to learn some utility or reward function that captures human values. I think this approach gets firmly established in the AI alignment and safety field by papers like Cooperative Inverse Reinforcement Learning by Dylan and others, and also this Deep Reinforcement Learning from Human Feedback paper by Paul Cristiano. And then finally, this goes really mainstream with OpenAI's InstructGPT paper, where RLHF is first used to align language models to follow instructions better. And of course, now there's a whole cottage industry of papers on how you can build or modify RLHF to better align AI systems. And I think the sort of concept of alignment has grown as it's gone beyond its initial context. Right, but I think there's still this sort of, focus on preferences in all this work. And our paper is actually a challenge to the idea that human preferences should be central to AI alignment. And this idea we call preferentism. And to be more precise, I think we can view preferentism as an approach where preferences or reward or utility functions, because these concepts are really tightly linked, are viewed as ontologically adequate, right? That we can define human values in these terms as epistemically central, that this is what AI systems should try and learn. And it's normatively basic. It's what AI systems should try to maximize. Put another, to get about that challenge, one of our contributions is to characterize this preferentist approach in more detail in terms of 4 separate commitments, which are often held implicitly or explicitly, even though not necessarily altogether. The first is the assumption that humans are well described as expected utility maximizers per rational choice theory. And the second, related, is that this is not just a good descriptive model, it's also normative. Humans should act as if they're expected utility maximizers if they're rational and intelligent enough. And so should the AI systems we build and design. This in turn leads to the idea that for an AI system to be aligned to a single human, it should maximize that human's preferences, represented as the utility function. And this can be generalized to alignment when there are multiple humans. In this situation, our AI system should maximize the aggregated preferences of all those relevant humans. Missed that slide, right? Just to illustrate this, the way that people tend to approach it is alignment both theoretically and practically. So model humans as having some unknown utility or reward function, then put them in some context and observe their choices, which can be binary preference judgments, can be demonstrations. And then we're going to align an AI system to the human utility function by estimating it from human feedback, such as those expressed preferences. And then we're going to give the AI system some different set of choices, such as actions or completions from a language model, and you tell it to maximize the learned estimate of a utility function, or sort of at least approximately maximize that. And in the multi-human case, you could aggregate different people's preferences. Cool. So that's sort of the model we're arguing against. And we do this by basically going through each of these theses and saying that this is why it's not quite enough, right? As a very brief overview, we argue that it's not good enough to describe humans as maximizing our utility or reward functions because this obscures and flattens the values and reasons behind our decisions. We also argue that utility maximization is not what we ought to do, and so we don't have to build AI systems in the shape of utility maximizers. Both of these imply a different conception of AI alignment, moving away from this concept where we align AI with a single human, but instead align AI with task and role specific normative criteria. And when there are multiple human stakeholders involved, this means involving AI systems, aligning AI systems to norms and standards that are agreed upon by those relevant stakeholders rather than their aggregated preferences. Right. So you can see this is a lot we're going to cover, which is going pretty fast, right? And so another way, going back to this graphical depiction, we're arguing for is a much richer conception of humans as rational agents, not just as agents who maximize utility or satisfy preference, but agents who act on the basis of reasons, reasons which may include goals, values, norms, and more. And over the course of this talk, I'm going to show you how we can build up this richer picture of human agency and how the process of aligning AI systems should reflect this richer structure. Okay, so any questions at this point? That's just a little overview.
Maybe you're going to cover this, but could I think of a norm as just something as part of my utility function?
Right, I am going to cover this, and I think you could view it that way, and I'm going to argue that maybe you shouldn't in some cases. Yes.
What might you say to the argument that the reason why we're focused on utility functions is because that's what we know how to optimize from a technical standpoint?
I think there are technical approach, multi-objective reinforcement learning is a whole field. I do think there are other approaches beyond just optimizing. And I think, the way I think of AI is AI ultimately are computer programs, and there's a rich space of computer programs you can write or learn that don't look like utility maximizers and can't be described that way, in fact. Cool, awesome. So let's start with this first assumption, the idea that humans can be described as utility maximizers as in rational choice theory, and see how that's not enough. And just to get clear what we mean by rational choice theory, we're treating it as a descriptive model of human decision-making, where humans are modeled as taking actions to maximize expected utility. In AI and machine learning, we typically relax this assumption a bit. We allow for noisy maximization, also known as Boltzmann rationality. And the reason we use these models, as in reinforcement learning from human feedback, is so that we can infer what humans in some sense really want from their outwardly observable behavior, like their expressed preferences, demonstrations, and so on. But it's quite easy to see how this assumption of utility maximization plus some noise is not going to be enough, right? Because humans aren't just noisily rational, we're boundedly rational due to all sorts of cognitive limitations. And this means that our outward behavior doesn't always reflect what we truly want. In RL from human feedback, for example, people are known to prefer responses that are longer as a heuristic for helpfulness, even though this is just a proxy, right? And in inverse reinforcement learning, where you try to learn a reward function from expert human demonstrations, people are just going to be suboptimal in computationally hard problems, right? Like chess or Sokobat. So already we can see how the standard model of human rationality is not quite enough, and how we might need to make a slight tweak to account for the boundedness of human planning and decision making. And to do that, we suggest turning to the framework of resource rationality, the idea that humans rationally trade off the cost of cognition with the benefits of action, perhaps in an evolved manner. Because this can explain why humans make mistakes when trying to achieve their goals, because sometimes it's just not worth it to plan that much, right? And that's sort of like in some cases, we don't realize that, in fact, that you should have planned more, right? In particular, we can model humans as resource rational planners and thinkers who don't always think fully ahead before taking actions, since thinking can be really costly. And this allows us to learn their goals and preferences even when they make mistakes when trying to achieve their goals.
Sorry, so yes. What do you think about, Kahneman's book is obviously about ways that people are not rational. And
yes.
Even in a much broader sense than this, that they're not rational, right?
Yeah, so I think the reason I like resource rationality as opposed to the heuristics and biases frame is an attempt to try and make sense of why we have these biases as rational for the kinds of bounded creatures they are, right? And if you think about like humans as evolved in a particular environment, you can sort of make sense why we would make these kinds of mistakes, right? And so we can sort of try and like, instead of, oh, we just make mistakes, try and understand like, what are other underlying reasons we would have made those mistakes. And so like, I think it's important to be able to like make sense of humans as rational creatures rather than just as a bag of heuristics. So that's sort of my brief response to that.
Okay.
Yeah. I think the paper by Falk, Leader and Griffiths talks a bit more about the contrast. Cool. So just to be really concrete about this, here's an example from some of my own work where we built this sort of human model where I'm showing you an agent who's trying to pick up this yellow gem in the top right. And to simulate how the agent is doing that, we're going to model them as planning only a few steps ahead, executing those steps and replanning as necessary. And with this sort of model, you can actually figure out what someone's trying to do, even when they sort of fail to achieve their goal. I'm going to sort of show this to you from an experiment we ran. So your task here is going to watch this agent, this little player character here, in this world where keys unlock doors and keys can only be used once. So once you use a key, it's gone, right? And so I want you to figure out, like, based on the agent's actions, what gem they're going for. So it's pretty easy to see what you have to do to reach the yellow gem. Blue is a bit harder, and red is a kind of hard one, but you see how to reach the red gem. Okay, now let's say you watch this behavior from this player. Okay, which gem were they trying to reach? I think people very intuitively say red, but they actually irreversibly failed to achieve the red gem, right? So if you, yes, the character knows everything about the environment.
They know where the lock.
Yes, they have complete full observability. Yeah. Yeah. But also, I think if you've played games like this, you would have made similar mistakes, perhaps in the past. And so when humans are shown this kind of behavior, you very naturally infer that the red gem is the goal. And it's because we understand that other people make mistakes sometimes. And our sort of boundedly rational agent model, when you do Bayesian inference over it, also recovers this posterior distribution of our goals that sort of reflects the human inference. But if you use this classic Boltzmann rational model, you just don't recover the same kind of inference. Instead, the explanation is that, well, the yellow gem is the only reachable one now. So like it must have been that the only reason the agent did that is like it kept tripping to the left and then upwards, because it's sort of explaining everything in terms of these action level mistakes instead of planning mistakes. Cool. So hopefully I convinced you we sometimes need this richer model of human decision making that isn't just maximize expected utility plus some noise, but still you could imagine making this change while insisting that this is just a change to the link between human preferences and their outward behavior. It doesn't seem to require moving beyond utility or reward representations of what humans want. So if you're the sort of person who really likes reward functions, you're in good company, because RL researchers like Richard Sutton have long argued for a claim called the reward hypothesis, which says that all of what we mean by goals and purposes can be well thought of as maximizing the expected value of the cumulative sum of a received scalar signal or reward. Right? But I think there are two big issues with this assumption. One of them is the issue of opacity. right? So I think utility and reward functions, even if you can use them, they sort of obscure the underlying semantics and richness of human goals, values, and reasons, which are defined in a really rich conceptual language. The other is the issue of scalarity, right? That utility and reward functions assume that we can always commensurate our goals and values into a single scalar value. That is, our preferences are complete implicitly. So let's unpack this opacity argument a bit more. So consider a goal that you might have as a graduate student in AI. So like, I want to get a paper into NeurIPS. It's almost never the case, though, that you just have one goal, right? You may also want to avoid losing too much sleep and to spend enough time with your friends. And when deciding what paper to write and also forming a paper plan, you also apply multiple evaluative criteria, like novelty or impact or technical soundness. And in executing the plan to write this paper, you don't just do everything you can to achieve your goals. You take yourself as beholden to various norms and constraints, like say avoiding plagiarism, ensuring reproducibility, and perhaps avoiding research that causes societal harm. Okay, I forgot to show this. So all these things are going on in your head when you're deciding to make this plan, right? And importantly, all these considerations I was just discussing are expressed in a really rich conceptual language, which thinking at the level of utility functions tends to obscure, right? Each of these criteria and constraints I just mentioned corresponds to an evaluative or normative concept, which humans learn a rich vocabulary of. And these concepts have a lot of thick semantic content. They're not thin, like the concept of goodness or reward, which just says better or worse, right? Consider a criterion like novelty, for example. The meaning of the concept and the computations required to evaluate it are actually quite complicated, right? You need to know the gaps in the literature and know the field really well to say, is this paper novel or not, right? Or consider helpfulness, which large language models are often trained to prioritize. What does that actually mean? Again, this is a rich and complex concept. One definition could be that an action is helpful insofar as it advances someone else's goals, right? And it seems like today's large language models may already have some understanding of that concept just by pre-training on tons of data, as explored in this paper on value as semantics, and that this may actually explain why we can easily tune them to be more helpful via reinforcement learning from human feedback. But I do think it's worth asking how well do large language models really understand these rich concepts that humans use all the time as we go about our lives? Are they really, understanding this in a really general matter, or just approximating it well enough over the data set they're trained on? Because in general, I do think determining whether an action is helpful can be a really computationally hard problem, right? Consider giving helpful advice on chess or some hard mathematical problem. You can basically embed these NP hard or worse problems in determining, in sort of like solving this helpfulness checking problem, which can make it hard for, say, transformers to solve in a single forward pass. So I do think it's like interesting to think about this empirical question. If we think it's important to represent these evaluative concepts well, how well do language models, for example, represent them? Great.
So regarding like this and the reward hypothesis, so there have been formal attempts to treat the reward hypothesis, say it's false, like David Abel's paper.
Yes.
I'm wondering, so this I know is a philosophy paper, but do you think that a formal, like, provable version of this statement would say that, so like in Abel's paper, they're saying it's impossible to optimize based only on the reward. It's not a computational issue. It's simply impossible.
Yeah.
Would this kind of be computational, like you're saying?
So no, what I'm saying here, really the main thing is like, I don't like the language of utility functions, or I don't think it's always appropriate. And I think, if we always talk in that language, we sort of like reduce our ability to think about what AI systems want is more of a sociological point than a sort of technical one, really. And just introducing these new concepts to all of you, hopefully that help all of us think better about what if we want to use utility functions, they better capture some of this, right? Utility functions are defined over some space of outcomes. That space of outcomes needs to be described in this really rich language that contains all these considerations. That's more what I'm trying to say. And you can think about this in terms of like representational alignment. Some people have talked about it. Yes?
Yeah, have you put any thoughts into the Maslow's hierarchical of need for human?
Yeah, I think that's possibly one way of representing the structure of human values. I'm not super committed to it. Part of what I'm going to maybe argue towards the end, I don't know whether I do this explicitly, is that I think the level of human model that we need, the resolution of it, is like kind of specific to the task we care about. And so some systems like general purpose AI assistants or your therapist AI probably do need to understand something like Maslow's hierarchy of needs. But like if you're just doing assistants which help you on short-term tasks, maybe they don't. For sure.
Maybe to like defend the alignment community a little bit here and get your take on this. So it does seem to me that a lot of people in alignment have like focused a lot on or like strongly agree with the limitations of rational choice theory. I'm thinking, for example, of a lot of work on logical uncertainty done by Yudkowsky and people at Murray. I also think like Stuart Russell believes so strongly that we have to build human models that it motivated him to not believe in deep learning for a long time, because he's like, yeah, we don't have any of these models of like all these resource rationality. I guess my question is something like, it feels like the way the community has hit a wall is just that there's nothing anywhere near as elegant or as clean or as simple as utility theory. And I'm curious, like, to what extent, like, it seems like, you know, the sort of rich vocabulary of evaluative concepts is like, it would be cool if we could like pin it down somehow, but like in practice, it seems like it's just going to be, there are like so many considerations that.
I think the thing I said about the resolution of the human models partly addresses that. I don't think we have to fully model things, but I do think in some ways now that we have large language models, we can make a lot more progress on this than before, because we can sort of learn the sum of the semantics of these evaluative concepts from pre-training. And you know, if you have a more formalist bent like myself and Stuart Russell, you can maybe synthesize these more specialized human models, which like capture just the semantics you need for the task. Like, you know, like write down code that represents the concept of helpfulness insofar as you can formalize that concept, for example. That's my brief.
So the idea here is that there are like concepts like helpfulness that could be formalized. Yeah.
Cool. I should go on. Yes. So so that's just opacity. Let's move on to scalarity, which I think gets back to this point more closer to David Abel's. So I've argued for this much richer picture of human motivations, but a very natural question is, can't we just compile all this stuff into a utility reward function at the end of the day, especially if this reward function is defined over a very rich conceptual space, such as the space of natural language, using something like a large language model-backed reward model, right? And you know, suppose we believe that language models do capture the semantics, and maybe this is enough. And I'm going to argue no anyway. Like, I'm also kind of skeptical of whether large language models do capture everything. But the reason I'm going to say no is that because these scalar utilities and rewards assume that we can always commensurate our different values and objectives into a single measure of goodness. But some choices are just hard. It doesn't seem like we can always decide whether one choice is better than another or even equal to each other, because they're just both good or bad in very different ways. Just to give a couple of concrete examples, again, from the grad student perspective, right? Which of these is better? You know, 1 nervous paper and 1 sleepless night, or 2 nervous papers and 4 sleepless nights? Which is better, a job at a dream school far away from your partner, or a job at an okay school, living with your partner, you know, if you're in a job search and like you may have to make this decision. Or which is better, living in a wealthy country with no democracy, or poor country with democracy? So all extremely hypothetical examples that have nothing to do with my real life. So we take seriously this problem of incommensurability. I think we do need to move beyond reward and utility functions if you want to model what humans are doing, at least. And start explicitly modeling firstly how humans commensurate our different competing values, or even fail to do so. Producing not a sort of full preference ordering, which would be represented by utility function, but a partial preference ordering, right? And there are a lot of interesting formalisms you could try and use to represent this thing, like interval value utility functions, a bunch of other stuff in this space could do that work. Great. So that was all just the first point. But that actually laid down a lot of the conceptual work. So hopefully the subsequent points will go a bit faster. Any questions in the meantime? Cool. I'm going to move on. Right. So let's move on to the second assumption, which is expected utility theory as a normative standard, normative theory of rationality. Right? Because one way you might react to everything I've said so far is that, well, sure, maybe humans can't be described as expected utility maximizers, but it's what we ought to do because it's what rationality requires, and we should build our AI systems to do the same. Right? There's a long tradition in economics that decision theory taken this more or less for granted in the form of the famous utility representation theorems like von Neumann and Morgenstern's, saying that if your preferences are so-called rational in certain sorts of ways, then you're going to act as if you're an expected utility maximizer. And in the classic literature on AI alignment, this is more or less taken as gospel, and it's assumed that advanced AI systems are going to comply with these axioms. So for example, you get this in Yukovsky's work. Typical justifications are what are known as Dutch book or money pump arguments, which try to show that if your preferences don't comply with the axioms of utility theory, then you can be exploited by a smart trader and hence lose all of your resources, right? Now, the problem, unfortunately, with these money pump arguments is that they aren't actually that strong and they don't always go through, right? As Thornley and Peterson have recently shown, agents with incomplete preferences, which can be described as maximizing expected utility, can resist exploitation by money pumps. And once you take computational attractability concerns into account, this nice paper by Kamara shows that for certain kinds of harder utility functions, and not even that hard ones, complying with the axioms of UT all the time is intractable, and they show this by this nice reduction to max 2-sat. Leibson and Yariv have shown that agents with, if you move to sort of more economically realistic settings, you might think, oh, when would people try and money pump you? Surely it's in a competitive market, right? But they've kind of shown this interesting counterintuitive result where in competitive markets, people with non-EU preferences can actually be protected from these sort of Dutch book traders, calling into the question whether money pumps are really likely to exist in real economies. And these non-EU preferences can actually be stable under evolutionary pressure. So there's a bunch of interesting theoretical results on that front. And the upshot of this, I think, these negative results, is that I think contrary to traditional arguments in the AI alignment literature, expected utility theory alone cannot tell us how powerful AI systems will behave and whether they'll behave like expected utility maximizers or optimizers. And we actually need to make further social technical assumptions before concluding that AI is going to function that way, right? I think, for example, some of Richard's work looking at the case of deep learning agents in particular, deep learning systems in particular, try and argue that maybe these systems can end up looking like powerful optimizers in the wrong direction. And also another offshot is that we're not forced to build AI systems to maximize utility or reward, right? Even if they get really powerful. And this maybe enables us to avoid some of the pitfalls of unconstrained optimization. Cool. I'll add this brief note as well. I've talked about how EU theory is sort of unnecessary, it's not required for rational agents. But I do want to point out as well that there's a sense in which it's also incomplete or insufficient, right? Because it's really just a theory of instrumental rationality. But humans also do much richer things like reason about what to value or reason about what preferences are justified to hold. And this process of normative reasoning, I think, really just isn't captured by sort of expected utility theory. Expected utility theory doesn't tell us what preferences we ought to hold in a certain sense. And I do think there's like a rich range of literature that we can draw upon, say preference logics, deontic logics, abstract argumentation frameworks that can help us formulate more formal theories of how people go about reasoning about what they ought to value with each other potentially. And maybe we can actually scale these approaches now with the help of large language models. Cool. So I've covered both the descriptive and normative claims of expected utility theory. What does this imply for aligning AI systems? So going back to this picture, right, the sort of traditional view of what you're supposed to do in alignment is you have this human utility function, you try and estimate it from human choices, and then you align the AI system to that estimate of the human utility function. Now, so I'm going to talk about how this picture looks quite different once you start taking seriously this sort of richer picture of human agency I've just given you here. And one final change I'm going to make is that I'm going to move this sort of context bubble from the bottom up to the top, because one thing I want to note is that humans prioritize different goals and values and assume different obligations and norms depending on their context and social role, right? And I'm going to argue that since AI systems are designed to perform certain social functions and certain social roles, the goals and norms for AI should also be context dependent, right? So the way I think, in some ways this is very obvious. I think the way we've mostly gone about designing AI systems is that we figure out the context they're applied in, we figure out what goals they should sort of work towards, what constraints apply to them, and then we sort of like build a system which sort of like tries to comply with all those things at once, right? Again, one way you can try and implement this is like using a reward function to capture all of these, validative criteria, goals, etc. And I think that's okay sometimes, right, in narrow decision context, right? If your context is narrow enough, that can be reasonable. The reason why I think it can be reasonable is because in such contexts, we can hope to commensurate all the relevant values we care about in advance, compiling it into a single reward or utility function. And the reward function effectively represents not human preferences, but a sort of context-specific normative criteria that we care about, that we want the system to care about. And I want to argue that, in fact, the current practice of reinforcement learning from human feedback should really be viewed in this way, right? It's not really about aligning a system to human preferences. It's about eliciting these context-specific normative judgments, such as, is this kind of text completion helpful, or is this kind of text completion harmful? And then aligning the system of these implicit normative criteria that can be learned from these judgments. So the preferences really are just data rather than the alignment target here. Yes.
When human annotators are used, do you know their context?
Well, I think they know some amount of context, right? They know that they're given the prompt and the completion is valid. Oh, their background, yes. I mean, I think it's really interesting to look at papers like this one by Anthropic, the OpenAI one, because the process by which they are selected is like very careful. And in fact, they're not only, they're not really aligned to their preferences, they're actually trained to sort of like apply certain kinds of standards. So there's a real sense in which the annotators are trained to like have some understanding of what OpenAI cares about or what Anthropic cares about, and then try and do that, right? So it's really like kind of OpenAI sort of approximate values or Anthropic's values that these systems were aligned to. And yeah, it's worth reading those sort of experimental details of those papers. It's quite interesting. Cool. So I think reward functions are fine in narrow context, but I think the big issue that we're kind of running into that makes sort of alignment more prominent again, I think, is that unlike traditional software and machine learning, I think large language model-based systems and similar systems operate across many contexts, right? And so reward models or reward functions trained on context-specific preferences are in general not going to generalize across this context. This can be viewed as a form of objective mismatch problem, where the sort of downstream evaluation metrics you care about just don't match the sort of thing the reward function is measuring. And there's some interesting work you can do to try and address this behavior, right? So you can build context-aware reward models. So there's this nice paper by Pittis et al. Working on this as a way of building basically essentially more steerable systems, sort of calling back to Taylor's talk earlier in this workshop, that can help adapt generalist AI systems to each context. But I still want to caution, right? I think this is kind of fine if you believe the AI systems can't actually manipulate this context variable, right? Once you start building AI systems which really try and maximize reward over context, then you get back into dangerous territory, right? In particular, one thing that an AI system would do once it realizes it can manipulate the context variable, and thankfully I think most large language models are not in this territory, is that they might sort of manipulate the user to change the context, right? For example, manipulate the user to ask easier questions. And this sort of nice paper by Micah Carroll, my co-author, sort of addresses this in a context of influenceable reward functions, right? I think he's more focused in a case where people's preferences change over the time. And again, in this setting, you have this incentive by an AI system to manipulate what the user wants in order to like get reward more easily. This is actually can be viewed as related to the shutdown problem in AI, where AI systems might be like incentivized to either shut themselves down or avoid shutdown to attain, again, more reward. So there's a sense in which I want to point this out because, there's a sense like reward functions aren't still quite enough. Great. Cool. So so context-aware preference models, I think, are sort of one technical implementation that can get around this question of like, oh, LLM systems do operate in many contexts, right? But I think that still doesn't really help us answer the question of like, well, what to align large language model-based systems or these generalist AI systems to, right? And I think because they're so generalist, it's tempting to forget that they do still function in the particular social role, right? Even large language model-based systems function in particular, for example, as conversational AI systems, right? I just took this nice picture at in Boston airport, actually. I was a bit surprised to see this giant ad there. I was like, oh, I reached San Francisco early. So we can still ask this question, given that Claude is a conversational AI assistant, what normative criteria should apply to conversational AI assistants, right? There's a bunch of things you can write down, right? I think that's a helpful way to think about what the alignment criteria are. And I think people like Anthropic have basically made a lot of progress on this question by turning towards techniques like constitutional AI, where the idea is you actually write down a list of principles that the AI system should follow. And now it turns out with these nice techniques for getting AI systems to generate their own judgments that comply with these principles. And then you can fine-tune the model to better comply with those judgments. So you can actually get these natural language principles and align AI systems to those principles instead of, to the reward function. Right? Or, the principles get compiled into a reward function in a certain sense, but the thing we really care about, at the end of the day, are these principles. And I think, these principles are for conversational AI assistants. One can imagine for other kinds of generalist systems, other kinds of normative criteria, right? And so just to sort of tie this to some work of my own work, right? So what normative criteria should apply not to conversational agents, but to instructable agents that execute tasks out there in the world? I think there are many criteria, but some of them I think that people are really struggling with right now in building these systems are, instructability is easy. That's a thing we really have now. But reliability, systematically achieving the user's goals across a wide range of conditions, and uncertainty awareness, I think, is something that's going to be increasingly important as systems act in a more sort of ambiguous context, among many others. And some of the work I've done on language-augmented goal assistance games, building upon this formalism that I think Dylan worked on, called assistance games, is an attempt to address that problem, right? So, in assistance games, you basically model humans as having an unknown goal. The assistant has a prior of a human's goal. You model the human as communicating and utterances, but also taking actions to achieve that goal. And from that, you can do Bayesian inference to infer the goal, and hence sort of safely help the human achieve their goals under uncertainty, right? And I view this, even though assistance games were initially proposed by folks like Stuart Russell as a sort of general solution to alignment problem, I think they actually should be viewed as something more narrow. They're just like a system requirement for higher risk instructable AI agents, right? For these kinds of systems, we really do want real-time, reliable, uncertainty-aware assistance. And so that's why we need to sort of start caring about these normative criteria. And the way we did this is we introduced this algorithm called Cooperative Language Guided Inverse Plan Search, or CLIPS, where, again, we have this Bayesian model. The interesting technical insight was that we can actually use large language models as a subcomponent of this Bayesian model of the user. We model how users would express their intentions in natural language, and then we can do inference to infer their underlying goals given natural language and actions, and are uncertain about what those intentions are if we ought to be uncertain. And so we can solve cases like this where this person placed 3 plates in a table and said, could you get forks and knives? This instruction is actually ambiguous, so you can't infer from the content of the instruction itself what you ought to do, but Eclipse is able to infer that the speaker's underlying goal is probably set the table for 3 people, right? And so hence get 3 forks and 3 knives. Cool. So that's a kind of different kind of system you could build by having this explicit human modeling process in order to achieve, I think, these other kinds of important normative criteria that I think conversational AI systems don't really account for very well right now. So all that was in the single agent context, right? Let me briefly remark a few things, some of the multi-agent context, right? So again, I think this sort of traditional view, one traditional or almost like naive view of what you should do to align AI systems to multiple human stakeholders is that you have multiple humans, they have different utility functions. We're going to aggregate them, and we're going to sort of optimize this sort of aggregated utility function. And there are a lot of problems with this sort of view philosophically, but I do think beyond the philosophical issues, there are actually a lot of practical challenges to this as well, especially in a sort of view I think that was prominent and in some ways still is prominent in AI alignment of like we're going to get super powerful AGI, and it's going to serve all of humanity's needs or something like that. And the problem is, among other things, it's actually really computationally intractable in general to maximize everyone's preferences. Inferring everyone's preferences is a really hard problem. We know from the kind of socialist calculation debate that there are informational and computational efficiency issues with like actually planning to satisfy everyone's preferences, what more under uncertainty. Of course, it leads to centralization of power, right, as a single point of failure if you build these single AI systems which optimize everyone's preferences. And it's incentive incompatible. We just shouldn't expect companies to actually be incentivized to maximize everyone's preferences in an impartial way. It's really an intention, I think, with the multiplicity of users of AI systems by different stakeholders. And just to remind us what we actually do want to use AI systems for, or at least how the AI economy currently functions, is that AI systems serve in multiple uses and roles, right? For individuals, for business corporations and cooperatives, and for communities and governments, right? And I take it it's by and large desirable that AI can serve these multiple ends given humanity's diverse and plural interests. But even if some of these ends are not desirable, perhaps surveillance and policing, I think we should nonetheless expect this kind of plurality to continue. And so I think all this motivates thinking about what alignment means at a societal scale. And given what I've discussed, I like to suggest 2 desiderata for any such approach. plurality. AI systems can be used for a wide variety of uses, but also safety, right? In the pursuit of those various goals, no one actually seriously endangers anyone's interest. And so the solution, can't be just sort of unbounded pluralism in a sense that, everyone gets to customize their own AI system in any way they want to their goals, because AI systems are going to impose negative externalities on others, right? And so instead, I think we can view productively the sort of multi-stakeholder alignment process as a form of contractualist AI alignment, where these norms and constraints that humans care about, when we're building an AI system, right, we should set them to avoid negative externalities and promote mutual benefit. And ideally, this process should involve impartial agreement by all relevant stakeholders. And one nice example of this already happening to some degree is this collective constitutional AI paper, where the collective intelligence project teamed up with Anthropic to run this sort of polis-style process to elicit from a large group of people what principles they should align the AI system to. And then it actually didn't just take the aggregated principles, they actually first identify different groups where people tend to disagree, and then look at the intersection of those groups and what they agree the most on, and then align the AI system to those principles instead. Right? But one sort of research sort of topic I'm really interested in is that I think for some classes of AI systems, you're going to want them to sort of learn on the fly what they should align, what criteria or what norms they should align themselves to. So I think of these as self-aligning contractualist agents. So for legal AI systems or future AI agents operating in sort of human AI economies, they need to sort of learn on the fly the norms as they change. And I do think this is a really interesting research program, I think sort of first proposed by Dylan and Jillian Hatfield in this nice paper on incomplete contracting AI alignment, about building AI systems that can reliably learn, predict, and respond to human communities' normative structure. And I've actually done a little bit of work on this and hope to do more in the future, where we introduce this idea of norm-augmented Markov games, where we build those agents that sort of understand that agents are not just motivated by their individual objectives, but their shared norms. And so by watching other agents, you can infer what the underlying norms that society has, and then sort of comply with the norms under uncertainty initially about what the norms are. And just as a little example of this, here's this norm learning agent, this little red character. Initially, it doesn't know the norms, is kind of like a baby in this environment. And it learns that it should do things like clean up the river, not eat too many apples, and so the environment isn't destroyed. And on the right, this agent doesn't learn the norms and ends up destroying the environment. And hopefully, even though we want AI systems to pursue our individual objectives, hopefully they can sort of take care of the environment in the same way that humans learn to do. Right? Cool. So that brings me, I think, to the end of the talk. Right, over the course of this presentation, I've talked to you about how we need to go beyond rational choice theory as a descriptive account of human behavior, and also as a normative account of what humans and AI systems ought to do. As a result, we should really rethink what alignment means and think about the tasks and role-specific normative criteria we want to align AI systems to, including the normative criteria that matter for, say, general-purpose AI assistants. And when thinking about these normative criteria, I think it's really important to consider that we live in a world where our AI systems are going to impose costs on each other. And so we really want to sort of negotiate the right kinds of norms and standards in order to determine what to align these AI systems to. Right, and so if we get this right, I'm just going to end on a bit of this corny note. As we take these challenges seriously, then perhaps our future with AI is not just one that we will prefer, but one that we truly have reason to value. And with that, I want to thank my co-authors once again, and I'm very happy to take questions.
Thanks for the great talk. We have a bit of a tight schedule, so maybe we can do one question, and then in the meantime, Aloni can set up so that he can make his flight. Thanks.
Question back there.
Yes.
Hi, thank you so much for the talk. So I buy the idea that human kind of reasoning about values, goals, and norms is context specific. What I'm curious about is whether that is a normative thing that we should strive for in AI systems. So as humans, we kind of have this conception okay, in general, we shouldn't lie, but in some circumstances, it's okay to do so, to not hurt someone's feelings or something like that. And I'm wondering if that's actually a desirable kind of property to replicate in AI systems.
So you want AI systems not to adapt to each context, or?
Well, I guess it seems like there's some norms that seem like they like potentially transcend individual contexts, like things like, you know, fairness or helpfulness.
Yeah. So I do think there's this like really rich hierarchical structure to human goals and values. And I think one of the things that's remarkable about human cognition and our ability to cooperate is that we're constantly revising like what we care about. And we are not just operating in one context, right? We sort of like, you know, think of cross context, or maybe say this, you know, this social role or this social context just shouldn't exist anymore. I do think, you know, humans do all those things. I think it's an interesting question to think about whether we should get AI systems to do the same. I think in many cases we don't. And the reason I think why we don't is that we often want AI systems to essentially function as AI, you know, services and tools. We don't necessarily want them to be like fully fledged moral agents, like taking their own sort of important decisions about the world. I mean, some people might argue for that in some cases, but I think for a large plethora of cases, I think we actually don't want that. That's my general take. Happy to chat more afterwards.
All right, thanks again.